Okay, so change of plan. The other problem I want to focus on is number 7, the Ferris wheel ride. And then I want to make a couple quick notes that might turn into more than that, I don't know, on number 14. So do number 7 and then a few notes on number 14. Okay, so a Ferris wheel. Hopefully we can agree that a Ferris wheel is round. So you've got this round circle here. And so if you've ever ridden a Ferris wheel, you enter on a platform. So this is the platform. I'm drawing a really rough sketch. And it's below. Now the Ferris wheel, that circle, does not touch the ground. So we have to think there's a distance from that platform, from that ground that you're standing on, to the actual Ferris wheel, that round part. Okay? So we want to say the radius. Radius, remember, is from the center to the outside of the circle. And that can be anywhere. So if I didn't want it there, I could say, hey, on the circle, whoa, that is not a good circle. It could be horizontally, or it could be the vertical down, or up. Okay, so that radius is indeed 30 meters. Okay, and then the lowest height, so all the way at the bottom, is 5 meters. So this distance here is 5 meters. Okay, if the Ferris wheel takes 40 seconds to complete the rotation, so starting here where you get on, and it doesn't matter which direction you go, either way, counterclockwise or clockwise or counterclockwise, it's going to take you 40 seconds to go around. Okay, so we want to draw a sketch of the graph that represents your height above the ground as a function in time. Time is usually our x. So if you want to label this t, you can, or you can say, hey, I'm just going to label this x. Your height will then be the y. If you want to change it to h, by all means, go for it. Okay? And here it does not matter whether you start, if you want to do sine or cosine. We'll talk about which one I would suggest here in a moment. Okay. So since the height will start there, it's always going to be above ground, so you know you're not going to go negative at all. But we need to come up with the values. Hopefully you notice the lowest height you will see, or you will be at, is all the way at the bottom. If you looked at a clock, that'd be at 6 o'clock, because 12 is up top, 3 is a quarter away, quarter of the circle away, 6 o'clock, 9 o'clock, beside the point. Okay. So the lowest point would be 5. If we're going counterclockwise, because we're going to focus on those main spots, that's why I talked about the 3 o'clock, the midnight, the noon, whatever, 12 o'clock, 9 o'clock, 6 o'clock. So over here, we know the radius of the circle is 30. So that's from this point to this point. Then we know that the distance from that point down to the platform is an extra 5. So this total height at both this 9 o'clock and the 3 o'clock would be 35 meters. Okay, so we know 35 meters. And then the highest point would be 30 above that, which would make it 65. Okay, so you have to think of the radius. 2 radii put together is the diameter, so 30 plus 30 is 60. And you have to think, how far is the lowest point from the platform? Okay, so in summary, lowest point is 5, highest point is 65 meters. And then halfway between would be 35. Then we know it takes 40 seconds to complete one rotation. So if I start, I have not moved at all, no time has passed, I'm down at 5. So if time is 0, okay, it takes 40 seconds to go all the way around. So that means it'll get back to your starting place of 5 meters at 40 seconds. And so this is represented by x. Okay. So at 20 seconds, that's halfway between start and finish. that's going to be up at 65. And as we talked about in the other videos, to find where it crosses that midline, so that 35, where it crosses that midline, will be halfway between 0 and 40, okay, or 0 and 20. So at a time of 10 seconds, I'm on the midline because that's halfway between my start and my max, so my lowest point and my highest point, and then halfway between the highest point and the lowest point, I'm back on the midline, and so the highest and the lowest points start or happen between 20 and 40 seconds, and halfway between that is 30 seconds. Okay. So again, I know the whole time to go around the circle is 40 seconds. So from the minimum to minimum, halfway I'm at the max. That's how I got 20. Then I find the halfway between the min and the max to find my midline value. And that's halfway between the 0 and the 20, and the 20 and the 40. Okay. So now to write an equation. The amplitude, which is A, is the distance from the midline to the max, also happens to be the radius, so that is 30. The period, how long does it take to start repeating itself? Well, it takes about 40 seconds, which means to find B, that is 2 pi, I have no idea where that is one. There we go. To find B, that is 2 pi divided by 40, which is pi over 20. Okay. From there, the phase shift. This is where we need to talk about sine or cosine. So if you could start at the max, so look at the max and say, okay, what is the shift? Go from there. Since the max, that would be cosine, it's a shift of 20. If you want to start with sine, I might recommend that it's a little bit closer to the sine function. I would say, this is for sine, would be 10 seconds. On my key, I have both sine and cosine, the phase shift and equations there. Okay. And, ooh, for a second there, I was looking at the wrong one. Here we go. And then the last thing is the vertical shift, which is D. And the vertical shift is how far the midline traveled from the x-axis. So that would be 35. Ooh, I wrote the wrong thing on my key. Sorry. Okay, so it went up to 35. So my equation, you would need to update this on my key. I accidentally just wrote 5. Y equals your amplitude 30. We said sine of pi over 20 times x minus the phase shift for sine, which we said 10, and then plus 35 because the midline moved from the x-axis up to 35. Okay. So that is number 7. Quickly here, I want to go to number 14. Okay, number 14. Just a quick thing here. What might be helpful is if you do like what I did on my key, notice that t equals 0 is January. So I wrote down January, February, March, April, May, June, July, August, September, October, November, December to help me with the numbering. So if January is 0 month, February is 1, March is 2, April is 3, and so on. And then I made a table. Sometimes working from a table before you graph is helpful. Notice we want month represented by T, and then daylight hours is represented by N. And so the months they gave us does not have to be in this order because T equals 0 is January. So it might be easier to put them in numerical order. But they gave us June, they gave us December, they gave us the average daylight in March, and then in September. So I would put 2, 5, 8, and 11, and then put the corresponding daylight hours with that. That would be 14, 12 with March, 12 with September, and 10 with December. My suggestion then, remember time is along the bottom. So remember that's T. And then daylight hours will be N as your y-axis. Okay. Otherwise, I have this key online. I just need to update number 11. Or no, number 7. That small error there. And otherwise, if you have questions, let me know. But this one I would suggest also using sine because it's a lot closer to the y-axis. That's what I calculated as. You could do this with cosine. Just notice your phase shift would be 5 instead of 2.